Happy Monday.
Happy Monday. How's it going, Joe?
Good. How's it going?
It's going all right. We're back again.
Yes, it's weird. Happens every week.
It happens very quickly. The weeks do not last long.
And I guess what is a week these days?
Yeah, yeah.
Um, yeah. So this week I think we wanted to talk about something that's been in our mind quite a bit, something that we actually label ourselves uh, since we've met and started working together. And I also think something that published an article about this morning. What is it? The recovering data scientist. This tends to get, I think, a lot of questions, a lot of odd looks.
Just very deliberate, right?
Yeah, yeah. I mean, we're usually not very clickbaity, but I think in this case, maybe coming up with something a bit controversial, it might be a good thing. So
Yeah, I think provocative can be good if it's actually useful, if it's not just trolly, basically, if it's not just provocative for the sake of being provocative.
correct.
There's a very valid point behind this idea.
Hmm. Yeah, yeah.
Subtle, in
So
fact.
yeah, it's an interesting one. I mean, every week I get a message from somebody asking, what does this mean? Like, what is a recovering data scientist? I'm not sure your experience or what people ask about it, but
People definitely ask me about it. Yeah.
yeah, I think it's an interesting question because right now I would say for the last several years, data science has been the hot thing. Everyone wants to get into data science, so why on earth would people like us, sort of shy away from it a bit? And I think we can get more into that. So, when did you realize you were a recovering data scientist?
Oh, that's a good question. I mean, I think the idea was planted in my mind well before. I think who coined the term? I think you and some friends coined the term, and I heard it from you. But definitely, as I was working and I kind of made the shift to data engineering, there was a realization at some point that the term data scientist was way overloaded, way ill-defined. It was very like buzzy, this is the cool thing. And yet it wasn't necessarily getting the job done, which is why I kind of ended up shifting to data engineering, because that was the key area of facilitation as I began to see it. Like if you can do data engineering, then maybe a lot of the data science becomes kind of easy.
Hmm.
And I think we're
Felt the
seeing
same
that
way.
now. Yeah. Yeah.
We're seeing it now. I think there's definitely more of an emphasis on uh, companies and tools and even just frameworks that are more focused on helping companies and data scientists develop more of a foundation upon which they can build their data science practice.
Yeah.
I know when I got into uh, ML data science, there really wasn't an established framework. I think we were all trying to figure it out as we went along, especially in terms of building the correct infrastructure foundation, as well as I would say just a general approach to machine learning. It wasn't as clear cut, whereas now it seems to be more clear cut. I do think that there's still quite a few data scientists that want to just jump straight into machine learning without taking the time to follow a framework or a process. But you know, uh,
Yeah, and when you do that, you end up just being kind of a dilettante. Like you're basically a hobbyist, right? Just hacking on some stuff on your laptop, which is great, but it's actually really hard to contribute business value to a company that way if you don't have good practices and systems in place. And the reality is most companies have some data engineering systems in place, but there's often a disconnect between what the data engineers are doing and what the data scientists are doing. And if they're not working together, then you're not going to see a lot of progress.
why do you think that is? Why do you think there is a disconnect between these teams or these people?
That's a good question. I kind of feel like there's almost this mad scientist mentality around data science. Like the cool thing is just to be hacking as opposed to actually doing real work in systems. And so sometimes the data scientists kind of turn up their noses at the people who handle the systems and handle the data pipelines and such and want to hack on things on their own instead of working collaboratively. And not collaborating is a great way to stall progress at a company,
Hmm.
frankly.
Yeah, that's an interesting one. I mean, we've seen this, I think, even at bigger companies who shall remain nameless, but um, I definitely see in situations where even at larger companies who are doing, I would say, some impressive stuff with AI,
Yeah.
there's still teams that are quite siloed and bifurcated. The software engineering team that handles a lot of the data engineering tasks the ML tasks, ML engineering tasks aren't really talking to the people writing the ML models. And
Yep.
it seems to be a case where the people writing the models just lob over the, the model over the wall to the engineering teams and tell them just to go deal with it.
Right.
And
And then the data scientists will complain about data quality. And it's like, well, you're not working collaboratively with the people who are responsible for
mhm.
data quality. Like, really, part of your job should be to get those data pipelines running appropriately. You should be in meetings with them. You should be passing issues back to them. And if that's not happening, then your data quality is not going to be good. And then your data science product won't be very good either.
Oh yeah, and that's communicating with the engineering teams. Like we had one case where somebody called and told me about a model that was taking, you know, almost a minute to retrieve results.
Yeah.
And at that point, the question is, well, is it the model or is it how you implemented it? But then that's where working with with engineers and data scientists, I think hand in hand is a good thing. And yeah, so I'd say things like this have made us, kind of recovering data scientists. I would say when, especially early on when data science became popular, it was called the sexiest job of the 21st century.
Yeah.
We can get more into that in a second too. I got some thoughts on that. But what was striking is it was sort of like this data science. I mean, that article came out in 2012, I believe, in HBR, but it was this belief that this data scientist was going to be this magical unicorn that would sprinkle the magic data science dust all over your company, and you'd suddenly become profitable and huge and attract talent and so forth. And in some cases, I think this has played out well. There's some great companies like the Googles of the world, the Facebooks, Netflix, Uber, and so forth that have really been sort of ML AI first companies. I think have done a fantastic job at integrating, and Amazon as well, integrating like the AI and engineering, because AI is a first class citizen at these companies. In companies where it's not necessarily a first class citizen, but that's where I think we've seen quite a bit of the the heartburn.
Yeah, and
Data
I think one of the
science.
comments about Google that I'm pretty fond of making is that everyone thinks of Google as an AI ML company. In fact, Google advertises themselves that way, but really I think of them as more of a data engineering company. Like, okay, there was PageRank, right? That's kind of what the whole company was initially based on. But they very quickly ran into a situation where they couldn't actually run PageRank. And that's where they invented MapReduce and later Colossus and all these other big data engineering systems that are the foundation for ML and AI. And so if you're a small company, you probably don't want to be reinventing the wheel. You want to go find what's out there and use off-the-shelf products and have a good data engineering team and then build on top of that.
Mm-hmm. Yeah, exactly. And there's some cool companies out there doing it. I think, have embraced a lot of the best practices they learned from the companies they worked at. Like Uber's Michelangelo, I think, became Tecton. And that's pretty cool. Stuff they're doing the features, and so it's cool right now because I think we may hopefully finally put to rest our recovering data scientist monikers. I would think in the next few years as data science tooling and practices become a lot more refined, and because it's cool what you're seeing is like people getting back to basics with data and not necessarily chasing shiny objects because it's a cool thing to do. I mean, that tends to happen still, but I think it seems like in the last year or two, there's definitely been more of a recognition that focusing on basics will yield a lot of long-term investment. And that kind of leads back to the data scientist as the sexiest job of the 21st century. It's been about 8 years since that article was written, and if data scientists were that sexy, then why were there mass layoffs of data scientists earlier this year with the COVID?
Yeah.
So
yeah, I know when I was initially hired, I was hired to be some kind of like magical unicorn, and it quickly became clear that that was not going to happen. And I think that's why these layoffs are happening. That executives and CTOs thought, okay, if I just bring in these PhDs with training in statistics, they can magically train my company. They hire the people, the systems aren't there to help these people be successful, and then they're not producing results. And then pretty soon you just kind of have this very expensive dead weight, unless you're willing to make the investment to go rebuild your foundations of data. And so a lot of people get laid off. It's an unfortunate situation. But I think if you're in that position, good luck in your search for a job. I hope you find something good, but also consider getting into some data engineering as well and expanding your skill set and making yourself more valuable to a potential employer.
Yeah, that's right. And what's interesting is, we're getting messages now from data scientists and data analysts who are interested in data engineering as a
Right.
new field. And and hopefully it doesn't seem like an infomercial for the kind of stuff we do. I would say in some regards, we do have a vested interest in data engineering.
Absolutely.
On the other hand, we started Ternary as out of necessity, really, because we saw, a lot of the data science efforts being hampered by a lack of good data architecture and good data engineering. So to the extent I would say that people might say, oh, well, you guys just want to push data engineering because that's what you do. I would say, yeah, that's totally true. And, I would love to see a day when I could get back into becoming, doing more data science work. I like machine learning. Somebody asked me the other day, do you like machine learning or data science? And I replied, yeah, I absolutely love it. And on weekends, I still check out the newest stuff, and work around with it. But it's not my full-time endeavor because I realize, it's the old stat: 80% of a data scientist's time is spent doing like non-algorithm, non-machine learning stuff. So like, why don't you focus your time there and try and raise the amount of time that data scientists are spending on data science stuff, which to me is like the ML, the analysis, and the things that are about either using humans to look at data and get value out of it, or using algorithms to get value out of data. Like, to me, that's what data science is. So.
Yeah, it's funny. It kind of reminds me of the story of Facebook Profit, which, as I understand it, was that basically Facebook had all these data scientists who were doing forecasting, and in practice, they were using pretty basic but powerful algorithms and just running a bunch of Excel spreadsheets manually, like again and again and again.
Mm-hmm.
And finally, someone realized, like, hey, why don't we just build some simple Python or R code that does this for them so that people can focus on higher level insights? And fundamentally, like, Facebook Profit is a data engineering type product that's meant to automate a lot of these steps. And so if you automate pipelines, if you automate data delivery, if you automate big data systems, then yeah, you're going to get a lot more value out of the data scientists that are getting paid these huge amounts of money.
Right. What's interesting too is data engineers, I think on average, get paid more than data scientists.
That's the funny thing. Like, it's the sexy career that people haven't heard of, right? Like,
yeah.
Everyone, at some point, you started to hear more savvy executives saying things like, okay, if I hire one data scientist, then I need 2 data engineers to support them. And that's a really key insight. And so there's a lot of demand in that area. It's just that your CEO may not be totally aware of what's going on with data engineering, and so it doesn't get as much hype, but it's definitely a really great area to look for career development. And I think a lot of people from my line, from my history, from my background in pure math, really enjoy data engineering because it is fundamentally logical problem solving. That's what it's all about.
Yeah, walk me through that. I mean, I don't have a math PhD, but you very easily could have gone into the machine learning route. I mean, what in your mind, in your experience, like what's in terms of the types of problems you would solve in pure math, like what's the difference between machine learning problem solving and data engineering problem solving? Like, why is one more attractive than the other?
Yeah, I mean, from my background, I didn't work in applied math, and I wasn't working in statistical problems so much. I was working in a lot of proofs and more deterministic problems in some sense. And so the process of like coming up with a proof for mathematical results is sort of similar to the process of building maybe a data system or debugging code or solving some kind of data problem where you're like, all right, this is what my data pipeline needs to do. How do I build a data pipeline that does X? I'm not thinking about statistics. I'm just kind of thinking deterministically, how do I get the data from A to B and transform it in this way that will make it actually useful? So I think there's a real alignment there in some sense between pure math and the data engineering world. Because again, pure math tends to be way less statistical than applied math or just studying statistics, for example.
Interesting. Now, that's a really good insight. I never even considered it from that angle before. I mean, is it sort of akin to how you would prove like a theorem then, or?
Yeah, exactly. Yeah, it feels like proving theorems in some sense. Like, I would say that my math PhD doesn't directly apply to the stuff I do day to day, but it feels very adjacent. Like, it feels like a similar set of problems that I work on in some sense.
Mm-hmm. Yeah, I could echo that. I mean, like, I remember even in my exit interview when I was doing my math undergrad, one thing I told the person I was talking with is I think the cool thing with math is it really teaches you it gives you a framework for thinking.
Right.
I think you're able to dissect problems from first principles, as much as you can, versus taking, sort of a hand-wavy approach. Because I did my, my emphasis is more on applied math, so almost the exact opposite of like what you
Yeah.
were doing. And I think
You're still
if I
learning
would
a
have
lot.
gotten a PhD, I would have, probably gone into like, more stats or probability as a PhD. But yeah, it's an interesting insight. Never thought of it from that angle before, because it makes a lot of sense. So.
Yeah, I mean, you think about the things you learn to do getting a math PhD. Well, you learn to write, you learn to communicate and teach, you learn to problem solve, like fundamentally. Actually, fourth, you learn to do research, and fifth, you learn to learn. In other words, you learn how to go into an area that you haven't seen before and pick up knowledge that's relevant to have kind of a holistic grasp of what's going on. And those are very similar to the skills that you need to be a data engineer or a software developer, for that matter, a really good software engineer.
Yeah, we share another friend who did his PhD in math as well, and he's an excellent software developer.
Yeah.
I mean, he's amazing at what he does, and I think it's in no small part because he's just got the framework for good thinking down.
Yeah, it's a transferable skill if you make the choice to transfer it. I think a lot of people from the academic background kind of struggle to make that transition, because you'll have to make a lot of other transitions at the same time, like moving from the academic world to the corporate world. But if you can do that, then there's a lot that you can contribute.
Mm-hmm. Yeah, for sure. So yeah, I think, I don't know if you agree. I mean, I definitely look forward to a day when I can stop being a recovering data scientist and
Right.
maybe even become a data scientist once again. But right now, I mean, it seems like there's bigger problems to tackle. I mean, the algorithms, there's still a lot of advancements in algorithms, and I'm really stoked on where it's going. I do see sort of these interesting parallel paths of AI research, doing some cool stuff where I think even like GPT-3 in a few years is going to look very quaint and downright simple compared to what's coming down the pipe. And that's rad. On the other hand, you have sort of this parallel universe of data science as it exists in most companies. And by most companies, I mean data science being done with structured data. And that is a fundamentally harder problem. It's a different problem to tackle. I don't know if it's harder per se, it's just different. And that's more of the stuff that we deal with. We don't deal with the AI research and the data pipelines around that, though that would be really cool to deal with. It's like, how do you get most companies to get value from data science and data analytics? These are the problems that I think we are more focused on tackling, and that's a lot of companies and that's a lot of people.
Yeah, it's funny too, even basic things like orchestration. So orchestration, making sure that the right job gets executed at the right time, that you can execute flows, that's still a really hard problem. I think Airflow is a fantastic framework, but it's also very painful to use in certain ways. It's very awkward in certain respects. And so I think we'll see a lot of continued evolution in that field, a lot of evolution of data processing frameworks like Spark or Apache Beam. All things which with structured data really feed the value on the data science side, where you have to pre-transform it to get it into shape. I mean, in some sense, that is the hard problem with structured data, is to put it in a form where machine learning can make some kind of sense out of it.
I mean, I would expect there's going to be a lot more advancements in that area as well. Pre-processing and I mean, ideally, you would just kind of remove the need for humans to have to handle structured data at all, just like it works in in other areas with unstructured data. But that's going to be a hard one to solve, because you also have to have domain expertise. I think that's kind of the unsung hero of data science. Is you can have the technical skills, but without the domain expertise to apply those technical skills, you're a person with technical skills, basically. That's what that is.
Yeah, and that's, in general, that's something that both data scientists and data engineers need to be careful of. I think I've certainly had this tendency in the past, and I've seen a lot in other people, which is to be dismissive toward the more non-technical domain experts, like, oh, I'm the smart person here. I'm the one who understands how to use Python and SciPy and all these other frameworks. Don't talk to me about what I need to do. And it's like, really, a lot of your job is actually communicate with the stakeholders, understand what they're actually trying to achieve, understand they have pretty good insights into their data. And you as a data scientist might show sometimes that their insights are not quite right, but they're a really good starting point from kind of a Bayesian perspective that domain knowledge is extremely valuable and something you need to use day to day.
That actually brings up a good point about the recovering data science angle, and one I didn't even address in the article I just posted, but there is a tendency, I think, for some data scientists to have sort of a know-it-all approach to how they conduct themselves, and I find it pretty distasteful. And but it's a school of hard knocks, right? Like when I started out early in my career, I would say I was much the same way. Like, well, math can solve everything. I don't even need input from people to know how to apply this, these formulas. And the rude awakening really is like, yeah, you do. You need execs to help you out, and you need business people to help you out, because let's face it, the business sort of operates with its own mission and uses data science to help further that mission. It's not really the other way around.
Right. Yeah. Businesses are organizations of people, right? Fundamentally. And executive's job is to kind of get people moving in the same direction, to come up with a path and then to execute it together. And sometimes we data scientists and data engineers are a little bit lacking in that area. There's a lot that we can learn about it.
It's a bit backwards sometimes. I'll give you a good example. Like, when I go to the even the Berkshire Hathaway shareholder meetings, when we look out in the crowd, it's like, you wonder, okay, so how many of these people know how to code or write machine learning algorithms or implement them? And it's like probably very few in a what is now a fairly big audience of people. And in this audience are people like Bill Gates and Buffett and Tim Cook and CEOs of like some of the largest companies in the world, let alone America. And I doubt any of these people know how to do much of anything that data science does, nor does it matter. Bill Gates probably does, yeah. But him being the exception, it's definitely it was a good thought exercise, because it's like, well, okay, then, but who's the one hiring of the data scientists? Are data scientists hiring people in the audience, or is it the other way around?
Right, exactly.
Who's adding more value? Who's adding more shareholder value in this case? Is it the exec or is it the data scientist? I think it's pretty easy to answer that one. I would say for data scientists that never mistake who runs the show, so to speak, and who's paying your bills. I would say some good advice is you definitely are equipped with a very robust technical skill set, but you definitely need to take the time to get to know the business, the stakeholders, and develop domain expertise, in the company that you work at or the organization you're a part of. And it goes without saying that, we touched on this a bit in other episodes of this discussion, but understand how your company makes money.
Yeah.
It's amazing how many people you talk to who actually don't understand how a company makes money, how their own employer makes money. It's insane, actually. I don't know how that happens, but it does. So.
Yeah, and especially as a data scientist, typically it's part of your job to kind of understand that. I mean, there are certain roles that are very R&D oriented, where someone hands you a problem and just says, go work on this one thing. But typically, especially in online retail, where we work a lot, data scientists sit pretty adjacent to marketing and parts of the company that are very responsible for cash flow. And so you should really try to understand what's going on in those areas and help to pay your own bills in some sense, right? Like help to bring in more money for the company so that they can employ you and other people to do good work.
Mm-hmm. Yeah, that's a big one. Some other advice too, I would say, is if you can orient yourself at the top of the funnel where money is made, so that's either sales or marketing. I think it gives you it sets you up to be a lot more business minded as well. And I don't know that's a bad thing. If you set yourself downstream in cost centers, I think that's an area where you're learning to play defense, and there's a big difference, I think, in how you approach problems when you're learning to play offense versus learning to play defense. So, when you figure out how to make more money, for example, that fundamentally changes how you view the world, the business you work in, and how you apply your skill set. So, it's a bit of a slight rant there, but I would say depending on where you want to go and depending how like recession proof you want to make your career, focusing on revenue driving activities and profit centers tend to be maybe more advantageous than fixating on cost centers. So.
Yeah, I would partially agree with that, and where I'm going to disagree is that I think there's a problem in the corporate mentality that looks on parts of IT as cost centers, when really, like, if I'm in online retail, my DevOps team isn't really a cost center. Like, by keeping the website up, they're making the company a lot of money. If all your SREs quit, see what happens a day later to your business. So there are multiple sides to this. I definitely agree that technical people need to understand how the company makes money. I also sometimes think that executives need to kind of reorient their thinking on what's a cost center and what's a cash generator.
Yeah, I think there's definitely a validity to that statement. And I guess it comes back to not just data science, but also engineering. Like, why is it that there's a perception of cost centers when they're really, perhaps, maybe money making or at least money preserving departments. So,
well, they're kind of upstream of the money making departments, right? And if you're upstream, then you're actually really critical. You're also part of the money making process. So.
Yeah. That's probably a discussion for another day. So,
yeah, this is a whole worms that we've opened now.
Yeah. Well, cool. So anyway, I think we covered some pretty good ground on recovering data scientists. Anything else you?
I mean, I'll just add, we don't intend to dismiss data science at all. Rather to say, rather we intend to say that maybe there needs to be a shift in priorities, which I think is already happening at this point. To make data science,
which is a good thing.
Yeah.
So audience, look forward to the day when Matt and I call ourselves data scientists.
Yeah. Recovering data engineers or something.
Yeah,
someday.
That'd be hilarious. Awesome. All right, Matt. Well, have a good day.
Yeah, take care.
All right, see you.